question is integral of log of 1 upon x minus 1 dx, limit goes to 0 to 1. Now we have to prove that this is equals to 0. Take the LCM in the first step. Now apply this property. Log of, instead of x, 1 minus x. Log of x upon 1 minus x. Now add equation 1 and 2. Y is equals to 0 to 1 log of 1 minus x upon x plus log of x upon 1 minus x. Again use the property here, log a plus log b is equals to log a into b. Log a into b. Log of 1. Again log 1 is 0. So the integral is, answer is 0. Now the next question is integral 0 to pi by 2 sine square x upon sine x plus cos x dx. Integral of sine square x upon sine x plus cos x dx. Again use this property. Integral 0 to a fx dx is equals to 0 to a f of a minus x dx. 0 to a f of a minus x sine 90 minus x sine 90 minus x plus cos 90 minus x. Now we know the formula for sine 90 minus x is equals to cos of x. Sine 90 minus x is cos x and cos 90 minus x is sin x. Use this formula here. Sine 90 minus is cos, so cos square x. Sine 90 minus x is cos and cos 90 minus x is sine. Limit is same. Again add 1 and 2. Y is equals to, denominator is same, sin x plus cos x. Sin square x plus cos square x. Sin square plus cos square is equals to 1. So 1 upon sin x plus cos of x. Now we have to put sin x as 2 tan x by 2 upon 1 plus tan square, and cos of x as 1 minus tan square x by 2 upon 1 plus tan square x by 2. Use this value here. Put this value. Sin x is 2 tan x by 2 2 tan x by 2 upon 1 plus tan square, plus cos is 1 minus tan square x by 2 upon 1 plus tan square x by 2. Now take the LCM. 1 plus tan square x by 2, 2 tan x by 2 plus 1 minus tan square. 1 plus tan square is sec square. So sec square x by 2 minus tan square x by 2, 2 tan x by 2 minus tan square x by 2 plus 1. Now we have the derivative of tan in the numerator. So put tan x by 2 as t. Derivative of tan is sec square, and derivative of x by 2 is 1 by 2. Now when x is 0, t is tan 0, and when x is pi by 2, t is tan pi by 4, that is 1. So limit goes to 0 to 1. I is equals to 0 to 1. Sec square x by 2 dx is 2 dt upon 2t minus t square plus 1. T square minus 2t. To complete the square, add and subtract half coefficient of t square, that is 1. Add and subtract 1 here. We can write 2 as square root of t square minus t minus 1 whole square. Integral of 1 upon a square minus x square is equals to 1 upon 2a log of a plus x upon a minus x. Limit is 0 to 1. Put the upper limit now. Log a plus x upon a minus x. Minus lower limit root 2 minus 1 upon root 2 plus 1. 1 upon 2 root 2 log of 1. Log 1 is 0. Rationalize here. Log of 1 is 0. 1 upon 2 root 2 log root 2 minus 1 square. A plus b, a minus b. A square minus b square. Root 2 square is 2 minus 1, 1. Log of x power m is m log of x minus log of root 2 minus 1 upon root 2. Now the next one is integral 0 to pi by 2 sine square x dx upon 1 plus sine x into cos x. First, use the property integral of 0 to a f of x dx is equals to 0 to a f of a minus x. Sin 90 minus theta, पिछले क्वेश्चन में हमने प्रीवियस क्वेश्चन में यही किया है. Sin 90 minus x is cos 1 plus cos of x sin x. Now add 1 and 2. Denominator is same. So sin square x plus cos square x 1 plus sin x cos x. Sin square plus cos square is 1. Now, in the next step, divide the numerator and the denominator by cos square x. 1 upon cos square, sin upon cos is tan x. Now we know the derivative of tan x is sec square x. So in the denominator, instead of sec square x, we write it as 1 plus tan square x. Sec square x dx 1 plus tan square x plus tan x. Now we have denominator of tan x in the numerator. So put tan x as t. Derivative of tan is sec square. Now when x is 0, tan 0 is 0. And when x is pi by 2, tan 90 is infinity. So limit goes to 0 to infinity. Sec square x dx is dt. T square plus t plus 1. To complete the square again, add and subtract half coefficient of t. Coefficient of t is 1. So add and subtract 1 by 4. dt upon t plus 1 by 2 whole square. Take the LCM here. 4 minus 1, 3 by 4. We can write it as root 3 by 2 whole square. Now integral of 1 upon x square plus a square. 1 upon a tan inverse x upon a. 2 upon root 3 tan inverse 2t plus 1 root 3. Limit is 0 to inverse infinity plus anything is infinity. When t is 0, 1 by root 3. Infinity is value of 10, pi by 2, and 1 by root 3, pi by 6. 2 upon root 3 2 by root 3, 2 pi upon 6. 2 pi upon 3 root 3. Two will cancel. So I is pi upon 3 root 3. Next one is integral of 0 to 1 cot inverse 1 minus x plus x square dx. Now we know the one formula. Cot inverse x is equals to tan inverse 1 upon x when x is greater than 0. Cot inverse tan is equals to tan inverse 1 upon x. Use this formula. Cot is tan inverse 1 upon x. Limit is 0 to 1. 1 minus, take x common, 1 minus x. In the numerator, add and subtract x. Now it becomes of form tan inverse a plus b upon 1 minus a into b. Tan inverse a plus b 1 minus a into b. This is the formula for tan inverse a plus tan inverse b. Tan inverse a plus tan inverse b. In the first part, now we use the identity property. Integral of 0 to a fx dx is equals to 0 to a f of a minus x. And what is the a here? 1. Tan inverse x plus tan inverse x. Both are same with the limits 0 to 1. So 2 times 0 to 1 tan inverse 1. And we know how to calculate or how to evaluate the integral of inverse function by taking inverse as first and 1 as second. First function as it is, integral of second, integral of 1 minus integral of derivative of first, derivative of tan inverse, integral of second. Now here complete the derivative by multiplying and divided by 2. inverse x minus 2x upon 1 plus x square. This integral is of form f dash x upon f of x log of fx, and limit is 0 to 1. 2 tan inverse 1 minus 2 into 0 is 0, log of 1 plus 0. Log 1 is also 0. Tan inverse 1 is the value for pi by 4 minus log 2. Pi by 2 minus log